Okay, so welcome back, and now in this example we're going to look at some recursive recurrence relations, so some sequences that are defined recursively, and we're going to use that information to find an explicit formula. So let's start. Okay, so in the first example we've got this sequence defined as follows. A sub 1 is 2, and then a sub n for all subsequent terms is defined recursively. A sub n is equal to negative 3 times a sub n minus 1 for all n greater than or equal to 2. So if we start, well, we've got a sub 1 is equal to 2, and then a sub 2 is just going to be what? It's going to be negative 3 times a sub 1, which is 2. So it's going to be negative 3 times a sub 1, which equals negative 3 times 2, which equals negative 6, right? And then what do we got? We got then a sub 3 equals negative 3 times a sub 2, which is negative 3 times negative 6, which equals positive 18. Okay? So far so good, right? Okay. So now what's going on here? So then we can keep going. A sub 4 equals negative 3 times a sub 3, which equals negative 3 times 18, which equals negative, 54. Okay, now here's the thing though. This is 2, right? And then a2 is 3 times 2, negative 2. But this here, let's go back to a3. Well, we can write this as what? This is equal to negative 3 times negative, hold on. Oh, hold on. Hold on, 2 times. Here we go. Hold on. Let me rewrite this here. Write it this way. So this is going to be 2 times negative 3, right? And then this one is going to be what? It's actually 2 times negative 3 times negative 3, right? Which equals 2 times 9. And then this one here can be rewritten as 2 times negative 3 times negative 3 times negative 3 equals negative 54. Because this is negative 27 times 2. So now we see a pattern, right? So we see that, well, what's really going on here? A sub n is equal to what? 2 times negative 3. Well, this is 3 to the first power, right? 3 to the second power, 3 to the third power. So what do we have here? This is going to be 2 times n minus 1 power. So let's see if that works. Well, if n is 1, we get negative 3 to the 0 power, which is 1. 1 times 2 is 2. And then for n equals 2, we get 2 minus 1, which is 1. So we get negative 3 times 2, which is negative 6. And if we do 2, right? 2 times, or excuse me, 3 3 minus 1 is 2, so we get negative 3 squared, which is 9, and 2 times 9 is 18. And so guess what? That is the final result. So this is our explicit formula. Okay, good. So now, let's look at the next one. So let's write a few terms and see what we get. Okay, so a sub 1 equals a half. A sub 2 equals what? A sub 1 plus a half, right? So this is going to be a half plus a half. Oh, hold on a second. What is it? Hold on. Oh, this is 2, right? So 1/2 to the second power. So a sub 2 is going to be a half, right? So a sub 1 plus 1/4, so a half squared. And so this is going to equal 3/4. Okay, so let's do a sub 3. So a sub 3 is going to be a2, which is 3/4, plus 1/2 to the third power, which is 1/8, which means this is going to be 6/8. So 6/8 plus 1/8 is 7/8. Okay. Now let's do another one. A sub 4 is going to now equal 7/8 plus 1/2 to the fourth power. And so this is going to be 7/8 plus 1/16. Right? So that's going to be, so we get 14/16, and plus 1/16 is 15/16. Okay, good. And then a sub 5, let's do one more. A sub 5 equals 15/16 plus 1/2 to the fifth power. And so that's going to end up being 1/32. And so this is going to be 30 seconds, but then 30 plus 1 is 31, so 31 30-seconds. Okay, so now let's look at the pattern. So we've got 1/2, and then we got 3/4. So let's do this. I'm going to erase this, give some more room. Okay, so let's write down the sequence of numbers. So we got 1/2, 3/4, 7/8, 15/16, and 31 32. Now, what's the first thing you notice? First thing I notice is that we've got 1, 2, and then we have 3, 4, and then we have 7, 8, 15, 16, 31, 32. So these are all like one away from each other. The top is one less than the bottom. Okay. Now, if I look at the top, I really can't see any discernible pattern. Okay. So let's look at the bottom. But the bottom, I do see a discernible pattern. It goes 2, 4, 8, 16. It's doubling, right? So the bottom has the pattern of 2 to the nth power, right? So let's write that. Okay, so let's write a sub n, and we've got the bottom, which is going to be 2 to the nth power. That'll take care of the bottom, so when a is 1, we get 2, And then when n is 2, we get 4, and so on. Okay? Now, what about the top? Well, let's use the fact that the top is 1 less than the bottom. Well, here's the bottom. Well, then, if the top is 1 less the bottom, then why don't we just write this as 2n minus 1? And there you go. That's it. And then we can rewrite this as 1 minus 1 over 2 to the n. Right? Or you could rewrite this as 1 minus 2 to the negative nth power. That'll work too. Okay, but typically we don't write it this way. So let's not do this. So either this way or this way would be fine. Okay. Okay, now what about the last one? Okay. So the last one has this recursive set. So it says A1 is negative 4, and then all the subsequent terms is defined by using this recursive formula here. And so again, let's write out the first few terms. So we start with negative 4, right? And then we've got what? 4 plus 6. So 4 plus 6 is what? Or excuse me, not 4 plus 6. Negative 4 plus 6 is 2. And then the next term is going to be 2 plus 6, which is 8. And then 8 plus 6 is 14, and then 20, and so on. Okay? So now, can we see a pattern here? Well, it starts with negative 4, and then we're adding 6. So, we could say a sub n is equal to negative 4 plus a multiple of 6. Which in this case would be 6 times what? It'd be n how do I want to do this? Let's think. Okay, so this is the first one, negative 4. And then the second term gives us 2, but that's for n equal to 2, right? So n is 1, 2, 3, 4, 5. So how can we do this? So, well, let's do n minus 1, right? So when n is 1, this becomes 0, and we get negative 4. If n is 2, we get 1, and we get 2, and so on. Now, again, I'm going to simplify this. And I'm going to combine like terms. I'm going to use the distributive property. So I get negative 4 plus 6n minus 6. Okay? And so this is going to be 6n minus 10. And so a sub n is defined by that explicit formula. And notice that it has the form of Cn or An, well, no, Cn plus b, I think is what we, or excuse me, minus b. or plus b, right? So b is just negative 10. And that's it. So that's it. See you next time.